Okay, so here you have methane and oxygen, methanol. Ada OH lah, methanol lah. Okay, let's say this is a block diagram for your reactor. You have two stream and then one other stream. Okay, so here you have O2, here is CH4, and then here is your CH2O and H. Okay, happen temperature at 300. Here, pressure 1 bar. Reaction is exothermic. Okay, you have temperature, pressure here, temperature, pressure here, and this is, you want to control temperature inside this. At the same time, you ada cooling system. Okay, this is your coolant. Okay, so with the assumption of outlet temperature equal to equal to the temperature inside, outlet temperature equal to temperature inside the reactor. That is the common assumption we made. So you can have your temperature element here, okay, and then goes to your temperature transmitter, goes to your temperature controller, temperature indicator controller, and then you have your control valve here. Since the inlet flow rate of coolant become your manipulated variable. Okay, what would be your disturbance? And you said that here the flow rate of this. The question is how this flow rate, let's say M1 and M2. So which one? Both? M1 or M2?
Both.
Okay, let's say you say both. Let's say you say, okay, new, okay, let's say both. How does this affect this temperature? Okay, this temperature means, because we assume outlet temperature, T outlet equal to T in reactor. Okay, not T in the reactor. Okay. So, how does this flow rate affect the temperature? If you have a clear relationship, if you can tell me how, let's say this M1 suddenly increase, your temperature is decreased by what relationship here, then I will agree with you that this is your disturbance variable. If you don't have that, so this is not your disturbance variable. Okay.
If got it?
If you got, what it is? What is it?
So no need to add something. No need to add the sensor or the if got.
Okay, what you got? What you got?
If the flow rate does affect the temperature lah.
Okay, if the flow rate does affect the
You
temperature,
need to add the sensor to control it lah.
what does it mean by sensor? You want to measure?
I don't know, like if the suddenly the flow rate change kan, so
okay, if the flow rate change,
if got the disturbance variable lah, so you need to have a control system to control it or not. Ada mau tambah lah. Control system sensor lah.
Okay. The first thing that I can say is this one. You did mention that your temperature is your control variable. Your coolant flow rate is your disturbance manipulated variable. Sorry. So within this system, actually, is you have to find the disturbance variable, not another system. If you put another system, then you need another controller. It's something else. Okay, if you have The problem is now, okay, I redraw this. Okay, this is your coolant. Okay, you have a control valve here, right? Then you have a temperature sensor, everything, temperature sensor, temperature controller, so that you want to, it will manipulate, open more or close more. If the temperature high, what the control action should do, what the controller should do, open more, so that the flow rate increase. When the flow rate increase, there will be more heat transfer from your process stream, from your reactor into your coolant. Okay, within this boundary, you should determine your disturbance variable. Not another thing. Not another thing here. It could be here. It could be. I know the answer. I know the answer. I just want you to think. Okay?
Coolant temperature.
Yes. Your coolant temperature can be your manipulated variable. Let's say your coolant temperature,
This can be
your DV. Your coolant temperature is your DV. Let's say it's initial inlet temperature. Let's say one day from your plant utilities, you will supply a coolant. Okay, let's say the temperature is 25 degrees C, cold water. Another day, don't know what happened to your plant utilities plant. The coolant is actually better, 5 degrees C. So which one will absorb more heat? 25 or 5? 5. Okay, when it absorbs more heat, at the same, let's say your flow rate, after running the plant for a few months, you can maintain it, let's say the optimum flow rate of coolant to cooling down your temperature at, let's say, I just say, okay, 20 liter per minute. Okay, but if your temperature, initial temperature is 5 degrees C, you might don't need this flow rate. You have to maybe reduce it because it can absorb more. Okay, then keep on check. That's why this inlet temperature of coolant become your disturbance. You get it or not?
yeah.